Hi, fifth grade. Today you're going to be working on Module 4, Lesson 31. And for this lesson, we're going to be continuing to divide numbers by decimals, except we're now going to be moving into much bigger numbers. And this is going to mean that we're going to need to do a standard algorithm for division instead of just doing the ways that we've been doing so far. So it's kind of like a mixture of what we have been doing, especially from the most previous lesson, to what we're now going to be doing today. So I'm going to show you an example of a problem and make sure you're copying this down into your notebooks. So what I'm going to do is I'm going to have 34 and 8/10 divided by 6/10. So what I'm going to first start by doing is writing my division expression as a fraction. So remember, to do that, I take that first number is 34.8, and I'm going to rewrite that as my numerator, and then my denominator is going to be this 6/10. So remember, the second number is on the bottom, the first number is on the top. Now, I still need to do that multiply part that we learned from the previous lesson. And from the previous lesson, you should remember that if you're dividing by something that is in the tens place, then you just need to multiply your number by 10. Now, the reason why I can multiply this number by 10 is when I divide this 6/10, it's also technically looking like this, 6/10. And since it's 6/10, when I find that reciprocal, that's going to be 10/6. So that is why I'm multiplying those numbers like that. But anyways, back to this. So what I now need to figure out is if I have 34 and 8/10 multiplied by 10, I now need to figure out what that equals. So if you have 34 and 8/10, that means that I need to move my decimal place over one time to the right, because I have that 1 0. So I move it over once to the right, which gives me my new number of 348. And I put that all over 6/10 times 10. That decimal moves over once, and that becomes 6. Now, when you get to 348 over 6, it is okay to not know how to solve that. Miss Coast can't even do that right off the top of her head either. However, what we are going to do to solve this problem is we are going to create a standard algorithm. And what I mean by that is we are going to be solving for 348 divided by 6. Remember, the first number is going to go inside the box, and the last number will go outside my box. And now I just need to solve this with the methods that we learned so far this year. So first I need to figure out how many times can 6 go into 3. It can't, so I'm going to think about how many times can 6 go into 34. Well, I know that I could do 6 times 6, but that's too big because that's 36. But I could do 6 times 5, because that is 30. So it's very important that you're practicing those facts. By now, you should know how to do the standard algorithm, so I'm not going to take too much time explaining this. If you need more help with it, please just let me know, and we'll do a small group. So now I'm doing 34 minus 30, and that gives me 4. And then I bring down the 8. And now I figure out how many times can 6 go into 48, and I know that 6 times 8 is 48, so I'm going to put an 8 up here. This is going to be my final answer, my quotient. So I'm going to do 6 times 8, which gives me 48, and then I subtract 48 minus 48, which gives me a remainder of 0, so that tells me that I'm done. Which means that my final answer to this problem, 34 and 8/10 divided by 6/10, is 58. And that is what we need to do for this. That's all we need to do for this problem. So the only difference between these problems and the last ones is that you're still doing the same steps. You're still setting up the division expression as a fraction. You're still multiplying it by either 10 over 10 or 100 over 100. And the only part that's different is instead of just figuring out the answer from here, you're doing a standard algorithm and then getting the answer, and that is it. So for the next part, what I'm going to be doing is I am going to erase all this, and I'm going to work on the next problem. So for the next problem, I have 7 and 36 hundredths divided by 8 hundredths. So I now have a new problem. Remember, my first step is that I'm going to take this division expression and I'm going to rewrite it as a fraction. So I'm going to have 7 and 36 hundredths all over 8 hundredths. And now remember, this isn't the part that I'm going to start dividing yet in a standard algorithm. I still need to multiply. So I'm going to take this, I'm going to do times. And I think about, is this like a 100 over 100 problem, or is this a 10 over 10 problem? This is definitely a 100 over 100 problem because I have this 8 in the hundredths place here. So I'm going to multiply this by 100 over 100. Because remember, whatever I do to the bottom, I'm going to do to the top, and vice versa. So now I need to figure out what my new number is going to be. So if I have 7 and 36 hundredths here and I'm multiplying it by 100, that means I'm moving my decimal 2 times to the right because I am multiplying. So I'm going to move it over 1, 2, and that gives me 736 all over. And now again, I do 8 hundredths times 100. Again, I move it 2 times to the right. So I move it 1, 2, which leaves me with the number 8. So I have 736 divided by 8. Now at this point, it is fine for you not to know how to divide 736 by 8, but that's why we have standard algorithms for these really difficult problems. So I'm going to set up down here 736 divided by 8, and let's go ahead and start solving these. So first I have to figure out, well, can 8 go into 7? No, it definitely can't go into 7. But can 8 go into 73? It can, and it can go into it 9 times. So then I'm going to figure out what 8 times 9 is, and that is going to give me 72. And now I need to subtract. So I'm going to do 73 minus 72, which gives me 1. Then I have to make sure I bring down that 6. And now I have to figure out how many times can 8 go into 16. Well, 8 could go into 16 2 times because 8 times 2 is 16. So I'm going to write that number down here. And then I'm going to subtract. And when I do 16 minus 16, I get 0. And this 0 lets me know I have no remainder, so I can now stop. This 92 right here is my quotient, my answer to this problem. So I will put that right there. And that is the final answer to this problem. So 7 and 36 hundredths divided by 8 hundredths is 92 hundredths. And that's all we got to do. And another way that we can check our answers is I can multiply these first 2 numbers right here. So whatever the first number is that you see in each set of decimals, so like I have a 7 here and an 8 here. I'm going to do 7 times 8, and then I'm going to figure out, is that number anywhere near that? If it's pretty close, then that kind of gives me an idea if my answer is correct. And in this case, it would be pretty close. So we're going to do that for the next couple of problems to help us out when solving these. So the next problem, I would like you to try this one on your own. So we're going to have 21 and 56 hundredths times 98 hundredths. So, divided by 98 hundredths. So go ahead and try to solve this problem. Remember, you're setting this division expression up as a fraction and then solving from there. So go ahead and do that and then unpause the video when you're ready to continue with me. All right, by now you should have done this problem, and if you didn't, please go back and complete this problem. So first we're going to write this as a fraction. So I have 21 and 56 hundredths all over 98 hundredths. Now, since I am in the hundredth space for this number that I'm dividing by, that means that I'm going to multiply by 100, and then I will get my fraction that I'm going to be trying to divide to get my final answer. So for this one, what you're going to see on your problem set is you're going to see problems that are going to have these little like thought bubbles above them. So it's going to have like a little squiggle maybe, and that's going to have like a little thought bubble. And what it wants you to think about, you're not actually going to be writing it or showing me the work. If you need to, you can. But you're actually just going to be thinking about this times 100 part. So instead of having to take all that extra time to show the work, what I'm going to do is instead, I'm going to imagine that I didn't have to write that part. And I'm going to think about, all right, well, if I have 21 5600ths and I know I'm multiplying it by 100, right now I am doing that work in my head. So this thought bubble right here actually shows me what I should be thinking in my head right now. So if I have 21 5600ths times 100, that means that this decimal is moving over 1, 2, and that's going to give me 2,156. So I'm going to write that as my new numerator. And then the same thing with the bottom part. I'm not actually going to write this step, but what I'm going to do is I'm going to think about it. So even though, yes, I am writing this down right now, I'm just showing you what you should be thinking when you get to this part. So I have 98 hundredths times 100, which means I'm moving my decimal place over 1, 2 times, and that gives me an answer of 98. So that will be my new denominator. So we're trying to make this process a little bit quicker. So instead of having to write all of this, you're now hopefully able to just think about it in your heads and then come up with the new fraction. That's all you have to do to come up with that. So if you see thought bubbles on your work, don't get freaked out or anything. It's just meaning that this is what it's asking you to do. So I'm going to go ahead and erase this so I have some more space. And now I'm left with this fraction, 2,156 divided by 98. And now what I need to do with this is I need to make a standard algorithm. So I have 2,156 divided by 98. And for this one, remember, 98 is the whole thing that's coming along. So I had to figure out, can 98 get into 2? No. Can 98 get into 21? No, it cannot. Can 98 get into 215? Yes, it can. Now I have to figure out how many times can 98 go into 215. And what would make the most sense is I can round this up to 100, and I can think about, well, 100 times what would be really close to 215? Well, I could do 100 times 2, and that would give me 200, and that's as close as I'm going to get to 215. So that sounds like a good estimate. And again, by now you should be able to do most of this in your heads. So we're going to be doing 98 times 2. So when I do that, I'm going to have 8 times 2. So that is going to give me 16. And then I'm going to do 9 times 2, which is going to give me 18. So I have 186. Now from here, I'm going to do the subtraction. But remember, if you're having a hard time with 98 times 2, it is totally fine off to the side to multiply that out and then check your work. So 8 times 2 is 16, and 9 times 2 is 18, plus 1, oops, I made a mistake, plus 1 is 19. So that's 196. So that is why we definitely want to check our work. Now, after that, I'm going to have to subtract. So I can't do 5 minus 6, so I'm going to cross that out. I'm going to cross out this 1 and borrow from it, so it's going to become a 0. And this 5 is going to become a 15 because I just added 10 to it. Then I do 15 minus 6, which is 9. And I can't do 0 minus 9 now, so I'm going to cross that out, cross out this 2. This will become a 1, and this will become a 10. 10 minus 9 is 19, and 1 minus 1 is 0. So now I'm going to bring down this 6. And look at that. We actually know how many times 98 goes into 196 because we just saw that number in the previous part of this problem. So I now know that 98 goes into 196 2 times, and 98 times 2 is 196. So I can just go ahead and subtract that. 196 minus 196 is 0. So there was a lot of kind of complicated subtraction that went on around here, but make sure you're just keeping track of all your steps, and you should be able to get this correct answer of 22. And that's really all we need to do for this problem. Now, I'm going to move on to the next problem, and also we could have checked our answer so I can think of what's 2 times 9. Well, 2 times 9 we said was 18. And 22 is pretty close to 18, so I would say we're on track with our answer. So let's move on to the next one. And again, I would like you to try this problem on your own. So this problem is 45 and 5/10 divided by 7/10. So we have 45 and 5/10 divided by 7/10. Try this problem on your own, and then you can unpause the video and work along with me. So for this problem, we're going to do 45 and 5/10 all over 7/10. And remember that thought bubble. I don't really, by now, I might be able to just do this work in my head, but what I'm thinking about is that I'm taking that 45 and 5/10, and I'm going to be multiplying that by 10 because this 7 is in the tens place. So I'm going to be multiplying this by 10, which I know in my head is going to be moving this decimal over one place value, and hopefully you're able to do this in your head. If you can't, it's fine to write the work down. We're just trying to make it a little bit quicker, and that is going to give me 455. So I know my new numerator is 455. Now I have to figure out my denominator. So I have 7/10 times 10 again, and that means that my decimal is moving over one time, which is just going to give me 7. So now I have 455 over 7, and those are the numbers that I need to help me figure out what the answer is. So from here, what I'm going to do is create the standard algorithm. So I have 455 divided by 7. So for this one, first I have to figure out how many times can 7 go into 45. Well, I know that 7 times 7 is 49, but that's just too much. So I'm probably going to have to do 7 times 6. After that, I'm going to do 7 times 6, which gives me 42. And then I'm going to subtract 45 minus 42, which is going to give me 3. Then I bring down the 5, and I do figure out 7 times what fits into 35. If you know your facts, this should be a really easy one. 7 times 5 is 35. So I do 7 times 5, which gives me 35. I subtract 35 minus 35, which gives me a 0. And then I'm left with my final answer of 65. Again, I could check my answer. 7 times 4 will give me 28. So it's not super close, but we're at least in the same place value. So that is how these problems are going to work. We're ready to move on to the next problem now. So if you got this answer right, awesome. But if you need help, please let me know, because our next problem is actually going to be very, very similar to what we just did. So now instead of having this 45 and 5/10 and this 7/10, I'm still going to have 7/10 for this problem. But now instead of having 45 and 5/10, I'm going to have 4 and 55/100 divided by 7/10. So this is going to change up our answer a little bit. So I want you to try this on your own and then come back together with me. So again, I'm going to set up my fraction, except this time I have 4.55. And then I'm going to rewrite this as 0.7 on the bottom. And remember, right now, I'm just thinking about how my decimals are supposed to be moving around. So if I'm dividing by a number that goes into the tens place, then that means I'm just multiplying both of these by 10. So if I have 4 and 55/100, that means I'm moving this decimal place over once to the right. So that's going to give me 45 and 5/10 all over 7. So it's a little bit different from before. Same numbers, just different values. Now, when I set up my standard algorithm, remember, it's fine to have that decimal in there. It's just going to be a little bit different. So I'm going to bring that decimal up, and I'm going to start solving just like I did before. So 7 number goes into 45. 6 times 7 times 6 is 42. Then I'm going to subtract, which is going to give me 3. And then I'm going to bring down this 5. So 7 goes into 35. How many times? Well, we said that's 5 times. Remember, I'm writing that number after this decimal place because this 5 that I brought down is after the decimal place. I do 7 times 5, which is 35. I subtract, and I'm left with that remainder of 0. But now my final answer is 6 and 5/100ths, or 6 and 5/10ths. And that is my final answer. So even though, yes, I had similar numbers, they were at different values. So that means that my answer is going to be at a different value. And that's all we had to do for this problem. If you have any questions, please make sure you're asking. And we're going to take a look at your problem set for today. So for your problem set, you're going to be doing number 1, A through B. Is going to ask you to estimate. You can if you want to, but I do just want you to do the at least the standard algorithms for the problems and getting those answers. For number 2, it's the same thing. You're doing A and B, and it's going to ask you to estimate, but you do not have to. And then for part 3, A through D, this is going to be the ones with like the thought bubbles on them. So it just wants you to explain what you're thinking about to answer the problem. So it's nothing really new that you're doing. It's just explaining your thinking in the bubble. So that's number 3, A through D. And then there's word problem number 4, and that should just be a 1-part problem. Then for your homework tonight, you're going to do 1, A through B, 2, A through B, and 3, A through D. So a total of 8 problems for homework tonight. And those are the exact same ones that I just mentioned, where they have the estimate. If you don't want to, that is fine. And then for the last part, it's going to have the thought bubbles. You just have to explain your thinking in the thought bubbles. So if you have any questions, please make sure you ask for help, and good luck.